Now we study about electric potential due to an electric dipole. What is meant by electric dipole? Consider two equal and opposite charges situated at a finite distance to form electric dipole. Definition of electric dipole: two equal and opposite charges, their magnitude is same but opposite charges. One is the positive, another is negative. Two opposite charges separated by a finite distance to form an electric dipole. Therefore, consider the electric dipole AB. Point positive charge is at point A and negative charge is at point B. The electric dipole length is twice L. Therefore, L plus L is twice L. Means O is the midpoint. Now, calculate the electric potential due to an dipole. Electric dipole. Due to that positive charge plus Q charge, the electric potential at point C due to that charge. Therefore, electric potential at point C due to plus Q charge. By definition of electric potential, V is equal to, but it's substituted as first charge, means V1. V1 is equal to 1 upon 4 pi epsilon 0. That charge is plus Q, means plus Q upon that distance Q upon that distance from point C from that charge is R1. Q upon R1. Similarly, the electric potential due to that negative charge, due to minus Q charge, is V2 is equal to 1 upon 4 pi epsilon 0 minus Q upon R2. That distance is R2 from that charge. Hence minus Q upon R2. But we can calculate the total potential, net potential at point C due to that dipole. Therefore, means both charges. Hence VC, potential at point C, VC is equal to V1 plus V2. Substitute the value of V1. 1 upon 4 pi epsilon 0 Q upon R1 plus 1 upon 4 pi epsilon 0 minus Q upon R2. But 1 upon 4 pi epsilon 0 means Q is taken common. Q upon 4 pi epsilon 0 in bracket. Remaining terms are 1 upon R1 minus plus minus minus 1 upon R2. Q upon 4 pi epsilon 0 in bracket 1 upon R1 minus 1 upon R2. Now, by using geometry cosine rules to find out 1 upon R1, first calculate by geometry using cosine rule. By using cosine rule, from that figure, R1 square is equal to R square plus L square, that distance L square, minus that distance is minimum from that perpendicular drawn are from the line joining to OC, means the axis. Axial axis, on the axis the perpendiculars are drawn, therefore r1 square is equal to r square plus l square minus 2rl, 2l or 2rl cos theta, and r2 square is equal to r square plus l square. That line extends about from O, therefore plus twice rl cos theta. r1 square is equal to r square plus l square minus 2rl cos theta, and r2 is equal to r2 square is equal to r square plus l square plus 2rl cos theta. Hence r1 square is equal to r1 square is equal to r square is taken common, therefore here 1, that factor remaining 1, plus r square l square upon r square, hence but r square is taken common, means l square upon r square, minus 2rl cos theta. R square is common, hence multiply by r square and divide by r square. R square is taken common and r get cancelled, means r1 square is equal to r square in bracket 1 plus l square upon r square minus 2rl cos theta, 2l cos theta, 2l cos theta upon r. Similarly, we can calculate the value of r2 square. R square in bracket 1 plus L square upon R square, but in the term of R2 here plus sign occur, means plus 2L cos theta upon R. Hence R square, R1 square and R2 square taking square root on both sides. Taking square root on both sides. And by using exponential, R is very greater than for L. R is very greater than for L. The electric dipole length is very small. Therefore, R is very large, means L square upon R square. R square is very large. Therefore, very small quantities occurred. म्हणून L square upon R square is neglected. Hence, L square upon R square is neglected. Hence, the remaining terms are R1 square is equal to R1 square is equal to R square in bracket 1 plus 2L cos theta, 2L cos theta upon R. But R1 is, the negative sign occurs, minus 2L cos theta upon R. And R2 square is equal to R square in bracket 1 plus 2L cos theta upon R. That values can be occurred. Hence, taking square root on both sides, taking square root on both sides, by using an exponential theorem, R1 is equal to, taking square root on both sides, R1 is equal to R in bracket 1 minus 2L cos theta upon R, bracket raised to half, taking square root on both sides. And R2 is equal to R in bracket 1 plus 2L cos theta upon R, bracket raised to half. that values can be substituted in the values of 1 upon R1 and R2. Substitute that value. We get the terms V is equal to, means potential at point C is equal to Q upon 4 pi epsilon 0 in bracket 1 upon R1. 1 upon R1, to calculate the value of 1 upon R1 is equal to 1 upon R in bracket 1 minus 2L cos theta upon R bracket raised to power is negative. In denominator we get the denominator term. Hence 1 upon R1 is equal to 1 upon R in bracket 1 minus 2L cos theta upon R bracket raised to minus R. Similarly 1 upon R2 is equal to 1 upon R in bracket 1 plus 2L cos theta upon R bracket raised to minus R. Hence substituting that value 1 upon R1 is 1 upon R in bracket 1 minus 2L cos theta upon R bracket raised to minus R, minus in bracket 1 upon R term is common in both terms, therefore 1 upon R and 1 plus 2L cos theta upon R bracket raised to minus half. Hence the net potential at point C, Vc is equal to Q upon 4 pi epsilon 0 into R in bracket. By using binomial theorem, 1 plus x raised to n is equal to 1 plus nx. 1 plus nx. By using that term, and we get the 1 minus twice L cos theta upon R minus L square R square terms get neglected. Hence minus 1 upon R1 and minus 1 upon R2. But here the terms 1 upon R1 minus 1 upon twice L cos theta minus 1 minus 2L cos theta upon R. That terms can substituting 1 upon R1 and 1 upon R2's value, therefore Vc is equal to Q upon 4 pi epsilon 0 into R in bracket 1 minus 1 get cancel. Therefore minus get plus 2L cos theta upon R. Hence the net potential Vc is equal to Q into 2L. By definition of electric dipole moment, P is equal to Q into twice L. Electric dipole, in the previous standard we learned about electric dipole moment. Electric dipole moment is defined as magnitude of any of the charge and dipole length, Q into twice L. Therefore Q into twice L, 1 upon 4 pi epsilon 0. 1 upon 4 pi epsilon 0, Q into twice L is substituted as P cos theta upon R. P cos theta upon R, where R multiplied by R. R multiplied by R is R square. Therefore 1 upon 4 pi epsilon 0 P cos theta upon R square. The electric potential due to electric dipole moment Vc is equal to 1 upon 4 pi epsilon 0 P cos theta upon R square, where r multiplied by r is r square term, but due to the single point charge, V is equal to 1 upon 4 pi epsilon 0 Q upon R. But due to the dipole, V is equal to 1 upon 4 pi epsilon 0 P cos theta upon R square. Now consider the two cases. Consider the point C is lie on axis. The point C is lie very near to the due to an electric dipole. Therefore, electric potential V is equal to 1 upon 4 pi epsilon 0. C point lie on its axis. Axis means the line passing through both charges, and center is known as axis of the dipole. Therefore, that line C point is lie on that axis. Therefore, theta is equal to 0. Theta is equal to 0 means cos 0 is equal to 1, means Vc is equal to 1 upon 4 pi epsilon 0 P upon R square. When the point lie on its axis of the dipole, means theta is equal to 0 or 180 degree. Therefore, 1 upon 4 pi epsilon 0 P upon R square. Because of cos theta, cos 0 is 1, means P upon R square. Means Vc is equal to 1 upon 4 pi epsilon 0 P upon R square. Now, when consider another case second. Case first, consider C point is on the axis of the dipole. Case second, C point on the equator. Equator means a line perpendicular to that dipole is known as equator, means theta is equal to 90 degree. Cos 90 is equal to 0. Therefore, the electric potential due to the point is lie on its equator, their potential cos 90 is equal to 0, means P cos theta. Cos theta is 0 multiplied by P, 0 multiplied by P is 0. 0 multiplied by 1 upon 4 pi epsilon 0, that term is 0. The net electric potential due to the point, when the point is situated on its equator, the net potential is V is equal to 0. Means potential is minimum when the point is on equator, and the potential is maximum when the point is on its axis.